One day, future humans must leave Earth for a new home among the stars.
Finding another habitable world is not just a science fiction dream. It has to do with the survival of humanity.
Today, astronomers are laying the groundwork for our move to a new Earth. But the more alien worlds they discover, the more they learn how deadly the cosmos really is.
The universe has this one rule when it comes to life: kill it all.
To pinpoint our new home, astronomers must unlock why space is so savage. What unleashed one of the most powerful blasts of energy ever seen to fry a promising alien world?
You would be dead so fast you wouldn't even know it.
How did our cruel sun destroy Earth's sister planet?
It just didn't make it and became this inhospitable hellscape.
We dive through waves of deadly radiation and plunge into suffocating atmospheres to reveal the raw, destructive power of the cosmos. Humanity's days on Earth are numbered. The sun's brightness will increase by 10% over the next 1 billion years. This extra heat will boil away Earth's oceans and incinerate all life on our planet. Our fate is written in the stars. We must leave and find a new home in another part of the galaxy.
To ancient people, the Earth seemed absolutely eternal. It must have always been here, and it always will be here. We know planets change. They live and then they die.
Our galaxy stretches 100,000 light years across. Where in this huge expanse is somewhere that can support complex life?
Planets are formed from the leftover debris from star formation. We have over 400 billion stars in our galaxy. That means we can have trillions of planets.
Astronomers call these alien worlds exoplanets. In 2016, exoplanet hunters make an exciting discovery. They find a rocky planet that is roughly the same size as Earth. The planet orbits Proxima Centauri, the closest star to our sun. They named the planet Proxima b. It is just 4.2 light years from Earth, and it is in just the right spot to potentially support complex life, like humans.
Finding Proxima b was a game changer, because not only is it a planet in the habitable zone of its star, it's the closest star to us. So this means that we could potentially go there. This changes the future directions of science on Earth.
The habitable zone is the sweet spot around a star, where temperatures are right for liquid water to exist on the surface of a planet.
If you're too close to the star, that water's going to boil away. If you're too far, it's going to freeze. And if you're in that zone, you can have liquid water on your surface.
The signs look good that Proxima b might have what it takes to be a home for humans in the future. But what astronomers see next puts the celebrations on hold. 2018, violent waves of radiation slam into Proxima b. The blast wipes out hopes that the planet can support life.
This is one of the biggest high-energy events involving an exoplanet that we've ever been able to witness. What could have caused such a huge release of energy?
Astronomers attempt to unlock the mystery. They examine the prime suspect, the star that Proxima b orbits, Proxima Centauri. Astronomers measure the light output from thousands of stars in our galaxy. A sudden increase in starlight is evidence that the star is releasing a stellar flare. A stellar flare is an explosion of intense radiation that erupts from a star's outer layers. Proxima Centauri is a red dwarf star. Astronomers discover that this type of star emits around 80,000 times more flares than a star like our Sun. Observations also reveal that each flare is around 1,000 times more powerful than the average type of flare that our Sun emits.
Small red stars have gigantic flares. They're so huge, they actually double the brightness of the star. That means the flare is as bright as the star is. So imagine if the Sun did that. Imagine if the Sun doubled its brightness right now. That wouldn't be good.
The evidence is clear. A super powerful flare from Proxima Centauri fried Proxima b. Splitting open the star reveals why it is so volatile. Proxima Centauri is so small that its core touches the churning layer of hydrogen that surrounds it. The extreme heat in the core drives streams of superheated plasma to the surface like a furiously boiling pot of water. Huge eruptions of plasma spew from the star with the force of 1 billion hydrogen bombs. The flares fan out through space. They slam into Proxima b and extinguish any chance that the planet can support life. Proxima Centauri discharges mega flares like this 3 times a year. These extreme flares will wipe out the ozone layer of every planet in the habitable zone of the star.
The Earth has a layer of protective ozone in its atmosphere that absorbs ultraviolet light from the sun, which is great because that kind of light is harmful to life on Earth. The problem with Proxima Centauri is that it is a flare star, and if Proxima Centauri b has an ozone layer, it'll get destroyed by this constant barrage of high-energy radiation.
The destruction of this layer ruins any chance that humans could one day live on Proxima b.
The kind of light that these flares emit is the kind of light that we use to sterilize surfaces. A DNA molecule would just be completely destroyed.
A new Earth must orbit a stable star to support complex life. The hunt for our next home continues. Can 3 newly discovered planets in the same system sustain humans on a thin boundary between fire and ice? And can a Jupiter-sized alien planet unlock the mystery of why habitable worlds are so hard to find? Humans must leave Earth before our sun incinerates our world and forge a future on a planet in another part of the galaxy. Today, astronomers lay the groundwork for our eventual move to a new planet. In 2017, they discover an extraordinary system 40 light-years away from Earth. A dwarf star called TRAPPIST-1 sits at the center of the system. Around it orbit 7 rocky planets, and all of them are a similar size to Earth. The planets are so close to TRAPPIST-1 that a year on these worlds lasts between 2 and 19 Earth days. 3 of the planets fall inside the habitable zone of the system. Could one of these worlds be our future home?
There are times as a scientist where you discover something out there that, honestly, if it wasn't right in front of our eyes, I would not believe that it exists. And the TRAPPIST-1 system absolutely blows me away.
Telescopes analyze the system in more detail. They reveal it is likely that these planets have unusual orbits. They do not spin around their star in the same way as Earth revolves around the sun. Instead, many astronomers think that the same sides of all 7 planets face their star. They call this tidal locking.
You can witness an example of tidal locking in action really close to the Earth. Just look up in the night sky and look at the moon. You only ever see one side of it. One face is always pointed toward the Earth. This is because the moon is tidally locked to the Earth. And what that means is that the time it takes for the moon to spin once on its own rotational axis is exactly equal to the time that it takes to orbit the Earth once.
The close proximity of these planets to their star unlocks why this happens in the TRAPPIST-1 system. The star TRAPPIST-1 is 20,000 times more massive than its orbiting planets, and its immense gravity grips them as they huddle in close. The star's gravity warps each planet, pulling out a huge bulge of rock on the side facing the star. The star tugs on the bulge like a handle, gently slowing the rotation of the planet. After millions of years, the planet slows down so much that one side remains locked, always facing the star. Living on a tidally locked world in the TRAPPIST-1 system poses a big challenge for future humans. The rotation of Earth ensures that no part of the planet gets too hot or too cold to support life.
It's the spin of our home planet that allows it to actually harbor life. It's this spin that evenly distributes thermal energy across our planet's surface and creates conditions hospitable for life itself.
But tidal locking turns the TRAPPIST-1 planets into super extreme worlds of two halves. It's likely that every planet in the TRAPPIST-1 system is tidally locked. Eternal darkness shrouds one face. The other is bathed forever in starlight. The star's powerful radiation roasts the surface of the day side, and water evaporates away. The night side experiences an endless cosmic winter. Water freezes solid as temperatures plummet. In between these two hellish half-worlds is a thin strip where it is always dawn. Temperatures here could be just right to support complex life. Any brave humans who do settle this thin strip will find themselves living on a knife edge. Huge megastorms will engulf the areas where the scorching winds from one half of the planet meet the frozen gases of the other. People here will live in a never-ending super hurricane. These megastorms raging inside this potentially habitable band make a TRAPPIST-1 planet too volatile for humans to live on long-term.
I don't want to say that life can't exist on a tidally locked planet, but if our species were to have its pick of a next planet to move to, we probably wouldn't pick a tidally locked planet as our new home.
Human space travelers in the future must search elsewhere for a place to live, but the odds of finding it are stacked against them. Just 2% of the over 4,000 exoplanets found so far are in the sweet spot of their star's habitable zones. Why are rocky planets within habitable zones so hard to find? Astronomers believe that a clue may lie in where they find another type of exoplanet. Telescope observations show that many exoplanets are gas giants made from hydrogen, like our Jupiter.
When you look at our own solar system, there's one planet that absolutely dominates, and that's Jupiter. Jupiter is actually large enough that you could fit 1,000 Earths inside it. And if you added up all of the mass of the planets, Jupiter would be about 70% of that. So when you think about what's really going on in a solar system, these giant planets are the story you need to tell.
The Jupiter in our solar system is almost 480 million miles from the Sun. But most Jupiter-like exoplanets discovered so far orbit less than 10 million miles from their stars. The super close proximity to their stars heats up the surface of these gas giants to over 7,700 degrees Fahrenheit. Why are these hot Jupiters so near to their stars? And does this closeness point to why future space travelers could find it hard to discover habitable rocky planets? One day, humans must leave Earth to find a new home among the stars. Astronomers today find few rocky planets with the potential to support human life in the future. What they do find are many gas giant worlds that orbit close to their stars. Do they unlock the mystery of why astronomers find so few Earth-like planets? A clue comes from special telescopes that unlock what gas giant exoplanets are made of.
Even though most exoplanets can't be seen directly, we can figure out what's in their atmosphere, because as they orbit the star and pass directly in front of it from our point of view, that starlight passes through their atmosphere. Different constituents in that atmosphere absorb specific colors of light. So by examining the colors of light, we can figure out what's in its atmosphere.
The telescopes discover something strange about the atmosphere of a hot Jupiter called WASP 39b. The data reveals that this planet contains water. How can a planet that's hotter than the surface of many stars contain a liquid that should vaporize in extreme heat?
Finding a planet with a lot of water in its atmosphere close to a star, there's no way that planet formed there.
Astronomers think the answer lies in the way that many gas giant planets evolve. Planetary systems start life as flat disks of gas and rock. A star ignites at the center. Its heat blows away lighter elements like water and hydrogen. But millions of miles further out from the star, it is cold enough to bind these materials into gas giant planets like WASP 39b. The huge gravity of the newly forming star pulls the gas giant closer and closer over millions of years. Eventually, the gas giant ends up so close that it becomes a hot Jupiter. Astronomers believe that many of the hot Jupiters they find in orbit around alien stars made the same journey. This death spiral could be one reason why future space travelers might find few rocky planets that could be our next home. A Jupiter-sized gas giant begins its journey towards its star. It steamrolls everything in its path. It's possible that it swallows smaller planets whole. A Jupiter-like planet's huge gravity smashes other planets together, and sometimes kicks them out of the system entirely. The planet eventually settles into a close orbit as a hot Jupiter, but it leaves a trail of destruction in its wake. Runaway gas giants could be responsible for the annihilation of smaller rocky planets and systems across the galaxy. It might be one reason why Earth-like exoplanets prove hard to find.
A hot Jupiter migrating towards its host star could wreak absolute havoc on the inner regions of an early solar system. Honestly, this ultimately comes down to the universe being a fairly unforgiving place. It's found many creative ways to make a solar system completely uninhabitable.
Hot Jupiters smash potential future Earths before they have the chance to flourish. But those planets that do escape the destruction can fall victim to other world-killing phenomena. Our own solar system shows future space travelers what disasters can ruin promising rocky planets. Venus is Earth's twin. Both planets are roughly the same size, and they contain almost identical elements in the same proportions. On paper, these characteristics make Venus a good candidate to support life. The reality is very different. Venus is the hottest planet in the solar system. The surface temperature tops a scorching 860 degrees Fahrenheit. That's hot enough to melt lead. And corrosive clouds of sulfuric acid blow through its atmosphere.
Have you ever had one of those days where it was just so hot and humid that you go outside and it feels like it's stinging your skin? Well, Venus is a lot worse than that. Imagine that, only you're in a fire and people are pouring acid on you.
Humans searching for a new home in the future could detect that a Venus-like exoplanet has many of the right ingredients to be a habitable world. Just like Earth, it might have the correct elements to support liquid water, an oxygen-rich atmosphere, and potential life forms.
Venus is in many ways much like the Earth. It's about the same size, it's a rocky planet. Billions of years ago, it probably looked a lot like the Earth. If it had an atmosphere like we did, it may have even had liquid water on its surface.
Why did Venus transform from a potentially habitable planet into a scorching hell? A clue lies in the data that the Venera missions beam back to Earth. The Venera landers captured the only photographs ever taken of the surface of Venus. These images show the hellish, baked planet up close. The instruments on board the landers record that the atmosphere of Venus is 95% carbon dioxide. It is the quantity of this gas that explains why the planet is so hot.
Carbon dioxide is a greenhouse gas. Light from the sun can warm the surface, but the carbon dioxide absorbs that warmth and won't let it escape back into space. So it's insulating the planet, and the planet just gets hotter and hotter and hotter.
Carbon dioxide makes up just 0.04% of Earth's atmosphere. This small amount of carbon dioxide in the air allows our planet to radiate excess heat into space and stay cool. If Venus and Earth are twin planets, born with almost identical elements and roughly the same proportions, then how did Venus end up with so much carbon in its atmosphere? And what turned the once vast oceans of Mars into frozen deserts? Our days on planet Earth are numbered. 1 billion years from now, humans must find a new home in another part of the galaxy. But how will future space travelers make the right choice when selecting the next planet to move to? Today, astronomers learn a valuable lesson from Earth's twin, Venus. Venus and Earth were born with the same elements and roughly the same proportions. But unlike Earth, Venus is now a burning hell with a suffocating carbon dioxide-rich atmosphere. How did two planets that started out so similar end up so different? A clue lies in where Earth stores its carbon. 4 billion years ago, megavolcanic eruptions release huge amounts of carbon dioxide into Earth's atmosphere. Water droplets inside clouds dissolve this carbon dioxide and carry it back to the surface as rain. Rivers flow to the oceans, and some of the dissolved carbon dioxide reacts with other elements to make calcium carbonate. Solid calcium carbonate rains down on the ocean floor and helps to form limestone rocks that lock away the carbon dioxide. This cycle over many millions of years packs almost all Earth's carbon into the planet's crust. But Venus turns this process on its head. What triggers a planet like this to release so much of its carbon from its rocks into the atmosphere? Astronomers believe that a clue lies in the light from groups of thousands of stars called open clusters. Telescopes measure the brightness of the different stars in these clusters. These observations reveal what could bake an Earth-like planet to death. The light from middle-aged stars is much brighter than the light from young stars of the same size and type. Scientists think that the reason why these stars get brighter as they age lies deep inside their super-hot cores. A star heats up and gets brighter as it burns through its nuclear fuel supply. Astronomers calculate that our sun was both 30% cooler and dimmer 4 billion years ago.
Our understanding of stars tells us that in the past, the sun was not as bright as it is today. That means that the planets would have been bathed in less radiation. So Venus probably would not have been as hot. It may have had rivers and oceans, and it may have been a place that could harbor life.
Venus shows future humans how an aging star, like our sun, can wreck a promising planet. Over the sun's lifetime, nuclear fusion inside its core generates more and more energy, which builds up in the surrounding hydrogen shell. The star heats up. This extra heat warms the surface of Venus 125 million miles away. The oceans on the planet evaporate, and the atmosphere fills with water vapor. This traps heat that bakes the rocks and forces them to release their carbon. This triggers a runaway greenhouse effect that pushes surface temperatures to over 860 degrees Fahrenheit. Venus shows how an aging star can transform the atmosphere of a habitable candidate planet into a thick, suffocating nightmare. Our solar system contains one more example of what a rocky planet in the habitable zone of a distant star might be like. And it serves as another warning to future humans looking for their next home. Mars is around 75 million miles further away from the Sun than Venus. Probes and rovers sent to the red planet confirm that it appears to be a dead, frozen world. But new evidence reveals that Mars was a very different place billions of years ago. The Mars Reconnaissance Orbiter takes super detailed images of the Martian geology. These photographs reveal the telltale signs that water shaped much of the landscape of Mars.
At one time, Mars had river valleys that were full, lakes that were full. It was raining, it was snowing. It was very much like Earth. Over time, this wonderful Earth-like world that was friendly to life turned into a dead, cold desert. What happened to Mars?
NASA's MAVEN spacecraft uncovers a clue in 2017. MAVEN monitors the atmosphere of Mars. The probe discovers that each year, around 35,000 tons of gas escapes into space from the atmosphere of the red planet.
Every single second that ticks by, Mars is shedding a little bit of its gaseous atmosphere into the void of space. And that's like stealing coins from a cash register every single day. Each individual theft is pretty small, but the amount really adds up over time.
The thinning atmosphere of Mars lowers the planet's atmospheric pressure, and liquid water boils away. The atmosphere cannot trap heat to warm the planet. In the past, Mars has what it takes to be a viable, habitable world. What is robbing the red planet of its gas? And can mysterious megageysers millions of miles from Earth redefine the search for a habitable planet? Humans in the future must find a new home in another part of the galaxy. Astronomers today scour the cosmos for planets that can support complex life. But our solar system contains a warning about how the galaxy can wreck habitable worlds. What transformed the oceans on Mars into barren deserts? The data from NASA missions to the Red Planet reveals a clue. It shows that the magnetic field of Mars is 40 times weaker than that of Earth. A planet's magnetic field is its protective armor against the sun. The sun blasts the inner solar system with an intense stream of radiation. The weak magnetic field of Mars cannot withstand this punishment. The sun's radiation rips away the Martian atmosphere, one molecule at a time. Astronomers think they know why the magnetic field of Mars is failing. The super-hot metal ball at the center of the planet is cooling.
We think that the magnetic field of a planet is generated by its rotating hot molten core. So the bigger the planet, the bigger the core, and the longer it takes to cool down.
The mass of Mars is around 10 times smaller than that of Earth. This difference in size unlocks why the magnetic field of the red planet is so weak. And it shows future humans looking for our next home. What can happen if they settle a rocky planet that is too small? 1 billion years after Mars forms, the planet is a water-rich world covered in rivers and oceans. Around it is a protective magnetic field that emanates from its churning molten metal core. But Mars is so small that it loses heat quickly and solidifies from the outside in. The core hardens and the flow of metal slows, disturbing and weakening the magnetic field. When this planetary shield fails completely, it exposes Mars to the scorching solar wind. Energy from the sun strips away the Martian atmosphere, and the liquid water on the surface of Mars evaporates into space.
If you would have visited our solar system billions of years ago, both Earth and Mars would have been these beautiful blue planets. But then if you came back today, you'd realize that something really changed. Mars had gone all wrong. And the difference between the two planets, one habitable and one probably not, is the mass.
Mars warns humans searching for a second Earth. How the galaxy can wreck viable planets in the habitable zones of stable stars.
When we look around our galaxy and our solar system, we see that the ingredients for life are everywhere. But you need more than just the ingredients. You also need the right conditions. The universe is a violent place, so being in a habitable zone does not guarantee your safety.
Liquid water is the key to sustaining complex life long-term on another planet. But where outside the habitable zone of an alien star can humans in the future find water in its liquid form?
When scientists first came up with the term habitable zone, they were thinking about how close a planet had to be to its star to be warm enough for liquid water. But perhaps we need to look farther out. Perhaps we've missed something.
NASA's Cassini probe uncovers a clue. Cassini studies the giant planet Saturn and its moons. In 2015, the probe takes this photograph of a frozen moon called Enceladus. It shows mysterious plumes blasting out at over 750 miles per hour from icy cracks in the moon's crust. Cassini grabs a sample from one of the plumes. Analysis reveals that it contains tiny grains of water ice and salty water vapor. This evidence leads scientists to a startling conclusion. It is likely that only liquid water under pressure inside Enceladus could blast out these plumes from the surface of the moon. And the huge quantity of water in each plume is evidence that they could come from a giant saltwater ocean locked inside Enceladus.
When you stand on the beach or take a boat out into the ocean, it seems like it's vast, just a huge amount of water out there. But in fact, it's only a tiny percentage of the total amount of mass of the Earth. On Enceladus, liquid water makes up a quarter of that moon's total mass.
Enceladus is around 750 million miles outside the habitable zone of our solar system. How is it possible for this moon to be warm enough to contain liquid water? And how does this heat transform the search for our next home world? Humans in the future must search beyond our solar system for a new home world. The galaxy stacks the odds against the existence of a second Earth in the habitable zone of an alien star. Today, scientists hunt outside the habitable zone for signs of liquid water, the key for sustaining complex life long-term. They find a secret ocean hidden below the icy shell of Saturn's moon, Enceladus. How is it possible for a moon over 900 million miles from the sun to contain liquid water? Astronomers believe that the answer lies with the huge gravitational power of Saturn. Saturn's immense gravity squashes and stretches Enceladus as the moon orbits on an elliptical path. This constant warping of the moon's rocky core creates friction and a huge amount of heat. As this heat radiates outwards, it melts the lower layers of the moon's icy shell to create a subsurface ocean. Cracks appear in the sea floor. Hydrothermal vents form in these gaps and pump minerals from the core into the ocean.
It's pretty amazing when you think about it. Being way out of the habitable zone, having a completely frozen surface, and yet still having a warm, salty ocean, that is cool.
Astronomers believe that our galaxy could contain 100 times more moons than planets. It is likely that there are trillions of moons in the Milky Way. A watery moon heated by the gravity of a huge planet could be a viable new home for humans in the future.
I remember when the idea came up that there could be undersurface oceans on these icy moons, and how amazing that was. But the thing is, there are more icy moons out there than there are rocky planets. If we're looking for liquid water worlds, maybe we should be looking for icy moons of gas giants.
If a giant alien planet is close enough to its star, and its water-rich moon has a thick atmosphere to protect against radiation, then it is possible for the moon to have liquid water on its surface. This moon could look like Earth.
The moons in our solar system that have liquid water oceans are all in the outer part of our planetary system. They're very, very cold. But what if we find a system out there that has a massive planet closer into the star? Now its moons are warmer. They actually could be Earth-like. There could be atmosphere, there could be ocean, there could even be life on an exomoon.
This isn't science fiction. This is actually entirely possible. Imagine standing on this lush world and looking up into the sky and seeing not only your sun, but this enormous planet that you're orbiting, filling half the sky.
NASA's new James Webb Space Telescope promises to revolutionize the search for alien worlds. This next-generation observatory will help astronomers study distant planets and their moons in more detail than ever before. It is possible that the discovery of a habitable Earth-like planet could be just around the corner.
Just a few decades ago, we didn't know of any planets around other stars. And someday in the future, people will talk about this time and say they didn't even realize there were other Earths out there. Things change fast. It's wonderful to be along for the ride.
Today's astronomers see a galaxy that is a violent, unpredictable place. Flares from superhuge stars fry planets instantly. Gas giants smash smaller, rocky worlds to pieces. Solar radiation bakes planets alive and strips them of their atmospheres.
What is for sure is that the universe does not make it easy for life to thrive. Some of these so-called habitable exoplanets might actually be these totally uninhabitable alien hellscapes.
But today's astronomers think that the galaxy contains many viable planets that future human travelers can make their homes.
Even though we know of a lot of exoplanets, and very few of them are potentially Earth-like, that doesn't mean there aren't lots of Earth-like planets out there. There are hundreds of billions of stars in the galaxy, and planets with conditions like our own are hard to detect for us right now. So there could still be billions of Earths out there.
Our future home could be a rocky planet around a sun-like star. It could be an ocean moon orbiting a gas giant. There are trillions of candidates in our galaxy. Our next home is out there, just waiting for us to find it.
In this video, I'm gonna show you how to cut MP3 file without any software. So open any browser and type mp3 cutter. In first website mp3cut.net. Open it and this type of interface appear. So open any file. You can also open from Dropbox, Google Drive, or directly from your device. So open any mp3 file which you want to convert. So I'm gonna open it, and now it's uploading or decoding. So now here is the audio file.
Our free podcast is made possible by
Now you can convert or trim in any part of this
bright Venus, the evening
audio.
star. But far,
You can
no one
trim
knows
from
the
left
sun
or
provides
right,
it.
or you can shift
This podcast is made possible by
anywhere.
contributions to begins to fall. To the day, Birth cluster is still around. Like
Now you can fade it, fade out, fade in, fade out. You can choose fade in second or fade out second. You can cut with selected part inside or outside. Now you can cut from typing minute in the below. You can volume up or down. Here is a speed changer. Pitch changer. You can up or down pitch. You can equalize any bases. You can change voice also.
by the combined graph.
This type of voice bases, you can change it. So here is a other file also. You can convert mp3 to another file also. Now I'm gonna save it. Now it's downloading. Now open it. This is the cutted version of mp3. That's much for today.